Hi everyone, hope you're all keeping well. Just a quick supplementary video just to kind of supplement some of the stuff we did last time on capacitors. So today we're just going to have a little look at some of the factors that affect the charging of a capacitor. So learning intention, of course, then will be to explore the factors affecting the charging of a capacitor. Hopefully by the end you'll be able to state what effect changing the capacitance has on the charging of a capacitor. So if you change the capacitance of a capacitor, how's that going to affect the time it takes for it to charge? And what happens if you change the resistance of an inline resistor? So if you increase that resistance or decrease that resistance, how's that going to affect the charging time for the capacitor? So let's start off with changing the capacitance. So if we change the capacitance of a capacitor, how is that going to affect how long it takes for that capacitor to fully charge? Well, let's first of all start with this equation here. So we have ourselves a DC power supply with a positive terminal and of course a negative terminal here. We have an inline resistor, so this resistor is just in series, and we have a capacitor here. So we have obviously our negative charges, our electrons, they flow along here, they flow through our resistor and they build up on this plate of the capacitor. On this side we have electrons leaving this plate and flowing along back along here to the positive terminal here. So we end up with a build-up of negative charges here and a build-up of positive charge here. So what happens if we change the capacitance here, that value for C of this capacitor? I'm going to show you a graph which will show you what happens to our charging time. So basically the first important point here is at the very start here you'll notice that the initial current is both exactly the same. Okay, so the initial current, if you have a small capacitor or a large capacitor, will always be the same. The initial current's not going to change. However, for a smaller capacitor, that's going to charge up much more quickly. So the reason for that is obviously it can hold less charge, so it's going to take less time to get less charge onto the plate. Simple as that. In the terms of a larger capacitor, it's going to take much longer to get the charge on there because there's more charge that you need to get on there. Now we also see this as a curve here. Now the reason it's a curve is because, as you remember last time, we talked about, when we were looking at energy, once you start building up a charge on this negative plate here, it starts to repel charges that are coming along from this power supply. So it actually slows them down. It slows down the rate that the current can move at. So what happens is basically this flow of charge will slow down as it travels along here. For the larger capacitor, obviously it's taking a longer time here. We just see a bit of a shallower curve here as well because obviously we've got more charge going on. It takes longer for that charge to slow down basically because there's more room for the charges to be stored on this plate. So that's exactly what's happening here. So quick note on this here, if the capacitance increases, the initial charging current will remain the same, but the capacitor will take longer to charge. Okay, simple as that. Now what happens if we change the resistance of that inline resistor? So let's stick with the same circuit here. We've got a resistor, we've got our capacitor. Here's what we see in this case. So we have a small resistor, we actually have a larger initial current. So this initial current starts off much higher. And the reason for that is quite obvious when you think back to just to Ohm's law. So if you're going to change the value of the resistance in the circuit, so if you're going to increase that resistance, remember if you want to then calculate your current, that's just I is equal to V over R. Now we've kept V exactly the same. So basically what's happening is we've kept V the same, we've increased R. So V divided by R, if R is bigger, then that number that that's equal to is going to get smaller. The number that that's equal to is just I, which is your current. So your current has to decrease. So if you increase the current, it's going to get smaller. So if you decrease the current, then obviously that means you're going to have to start off with a larger current. However, likewise, we're still going to have, because we've got this higher current to start with, we're able to push that charge on much quicker, so it's able to charge up your capacitor much quicker. However, as I said, if you've got a larger resistor, you start off with a smaller current. Because you've got a smaller current, it's able to push that current through the resistor much more slowly, so it takes much longer to get your capacitor fully charged. It's as simple as that. Here's a quick note on that. First of all, with a small resistor, the starting current is larger, but the time taken to charge the capacitor is lower, so it takes less time to charge the capacitor. With the larger resistor, the starting current is lower, so the time taken to charge the capacitor is longer or greater. Okay, and it's as simple as that. That's all I wanted to say today. So success criteria, hopefully you can tick both of these off. I can state what effect changing the capacitance has on the charging of a capacitor, and I can state the effect changing the resistance of a circuit has on charging a capacitor. Now I'm going to pop up some questions here. What I'm going to do is I'm going to pop up some questions from the purple book. I'll take a scan of them and I will pop them up along with some answers. I'm also going to pick out a couple of questions, a couple of past paper questions. Now I want you to make sure you have attempted these past paper questions before the end. And what I'm going to do is I'm going to get you to take a picture of the past paper questions and submit them as part of the assignment here in Google Classroom, okay? And I'll try and get you some feedback on them as soon as I possibly can. The other thing that will allow me to do is just kind of monitor who's actually kind of able to complete this work at the moment. Okay, so as always, keep yourself safe. Make sure you've commented below so that I know that you've actually engaged in the work, and make sure you obviously submit the work on Google Classroom as well. Okay, see you later, guys.